Hello everyone, welcome back to my channel. Today we are going to talk about injectors. I want to investigate three types of injectors: Piezo, HEUI and GDI. These injectors differ mainly in how they operate, the type of engine they are used in, and how fuel pressure is created and controlled. Let's go. At first we have Piezo injector. A Piezo injector is commonly used in modern diesel common rail systems. You can see common rail system, and this is a slide. But how it works? It contains a piezoelectric crystal stack. When voltage is applied, the crystals expand very quickly. This movement directly opens the injector needle and sprays fuel. And HEUI or HEUI injector. This system is mainly don't use a high pressure mechanical fuel pump. Instead, it is intensified using the engine oil pressure. Okay? In simple terms, engine oil, after that intensifier piston and increase fuel pressure, and then injection. What's the difference between these two types? About pressure source. In HEUI, engine oil pressure, and in common rail we have high pressure fuel pump. And about pressure generation, we have intensifier piston in HEUI, and in common rail we have central pump. Central pump feeds the shear rail, and in the same way. Okay, but what about GDI injector? GDI injector, gasoline direct injection, which is used in gasoline engines with direct injection, consists of several main components. Its structure is similar to solenoid injectors, but it is designed to operate at much higher pressure. Okay. How it works? Fuel is injected directly into the combustion chamber, okay, instead of the intake manifold. A high pressure fuel pump supplies the injector. Okay, and you can see the GT power model of GDI injector here. Actually, main components of a GDI injector are at first electric or electrical connector, solenoid coil, armature, needle valve, injector needle, return spring, injector body, fuel inlet, nozzle, sling ring. Okay. So, in simple comparison, Piezo is very fast, high precision injector used mainly in modern diesel common rail systems. HEUI, diesel injector that uses engine oil pressure to generate injection pressure, and in GDI, gasoline direct injection system that sprays fuel directly into the cylinder. And let me say, a GDI injector must produce a very precise and finely atomized spray because the fuel is injected directly into the combustion chamber. Okay? Therefore, the design of the nozzle and the angle of the spray holes play a critical role in combustion quality. Here we have an example from GT Power examples. This example model shows the detailed modeling of a GDI injector. One picture demonstrates a single injection and one demonstrates a split injection, okay? So, like many GDI injectors, the example model has a drilling in the needle, allowing fuel to flow from the rail to the needle seat. This drilling is represented by the needle pipe 1 part on the map. As the needle is lifted, the fluid within that pipe is accelerated. The acceleration of the fluid in the pipe is accounted for by linking the body force acceleration attribute in the pipe to a mass on the map. So this will apply the acceleration of the mass to the fluid within the pipe. The plot on the left shows the static pressure plot in needle pipe 1 at various locations along the pipe length. Okay, let's go to Piezo injector again. Main component. Piezo injector consists of several main components. At first, Piezo stack. What's the duty or task of Piezo stack? A set of piezoelectric crystals. When voltage is applied, they expand slightly. This small movement is used to open the fuel path. Number 2, we have hydraulic coupling or amplifier. Because the expansion of the Piezo stack is very small, this section amplifies and transfers the movement to open the injector needle. Okay. We have control valve that regulates the fuel flow or pressure inside the control chamber. By changing the pressure, it causes the injector needle to move. And needle valve or injector needle, the component that opens and closes the nozzle outlet. When it lifts, high pressure fuel is injected into the cylinder. And we have nozzle, control chamber, return spring. And what about the return spring? After the voltage is removed, it returns the needle to the closed position. An electrical connector. So, in summary, the operation sequence is ECU, voltage applied to the Piezo stack, then crystal extension, control valve activation, pressure change in the control chamber, then needle movement, we have needle movement, and fuel injection through the nozzle. Okay. I want to repeat that. At first, the ECU sends voltage to the Piezo stack. Piezo crystals expand movement of fuel electrons. This movement is transmitted and amplified through the hydraulic coupler. The control valve opens, causing the pressure inside the control chamber to change. The pressure difference lifts the needle. High pressure fuel is injected into the cylinder through the nozzle and its very small holes. Okay, and I want to say the actual movement of Piezo stack is only about 30 to 40 micrometers, but the hydraulic mechanism inside the injector converts this small movement into enough displacement to open the injector needle. And about the model that we have here, model of Piezo actuated common rail injector with a relatively high level of detail. Okay, the model accounts for the internal flow passage, mechanics of the needle and control valve, and the hydromechanical interaction. The piezo actuator is modeled using the force piezoelectric template. And absolutely, this example demonstrates the use of flow, as I said, mechanical and fluid mechanical templates to model a piezo-actuated common rail injector with a relatively high level of detail. The interaction between the hydraulic and mechanical components is modeled through fluid mechanical templates. The injector dynamics are thus predicted based on geometry and physical quantities describing the components. In this example, flow comes from the rail jetty that splits the flow into two passes. One flow pass is to the fuel gallery, and the other is to the control volume via the inlet orifice. Okay, let's go to HEUI operation sequence and main components. We have solenoid, spool valve, high pressure oil, intensifier, piston, plunger, needle and nozzle. And actually, solenoid activated by the ECU command opens the high pressure oil passage, and then a spool valve directs high pressure oil to the top of the piston. When power is cut off, it opens the oil drain pass. Then high pressure oil supplies by a high pressure oil pump. Typical pressure range is 500 to 3000 psi depending on engine load. An intensifier piston, a piston with a large to a small area ratio. When oil pressure acts on the larger area, the fuel pressure on the smaller side increases proportionally. And plunger compresses the fuel, needle and nozzle, similar to other injectors. When fuel pressure exceeds the needle spring force, the needle lifts and injection occurs. Okay? And you can see operation sequence here at first to seventh. And this is the model of GT power examples on the right side. This example is designed to demonstrate how components can be used to model a hydraulically actuated and electronically controlled control unit injector type in diesel fuel injection system. And the system contains an environment object. You can see in the picture. To model a constant low pressure source supplying fuel to the injector. The fuel from the low pressure supply flows out to pipe, representing the lumped effects of the entire low pressure system. And about downstream of the pipe is the valve solenoid connection object that controls the flow into and out of the high pressure pump chamber. The high pressure fuel from the pump chamber goes to the injector section of the unit injector system. The high pressure pump plunger displacement is achieved through a hydraulic force generated by a low pressure oil pump system